All right, so this is CNIT 129S. We're in the second class, so we're going to talk about Chapter 3, and I'll demonstrate the Command Injection Project, ED 102, which is a very important vulnerability, and it'll come up later when we get to the Web Security Academy. And if anybody wants to add or anything, I'll process, just make the online requests, and I'll approve them all later after the lecture. It will hurt Trump. Most of the remaining have Trump as second choice. Well, I think that would help Trump if the RFK voters have Trump as their second choice. But anyway, I guess we're going to find out. Anyway, so let's start with this here. So web technologies are, of course, essential and to understand. And this is the big issue, and modern websites are very complicated. And in that complexity comes all the security flaws that we're going to see. So let me make this bigger. All right. So HTTP is the fundamental problem, one of the many fundamental problems underlying the internet, are that it was originally designed for a very different purpose than it is used for today. The original concern of the very early internet was that you could service a lot of customers with very slow machines and very slow internet connections. So they made a simple protocol where it's connectionless, which means you send one request to the server, you get one response, and the server is now done. It does not have to maintain a session or remember who you are or anything. It's a single-step transaction, so each transaction can be handled separately. So that's the plan, and this was appropriate for web pages like mine, old-fashioned web pages that are just static content, and there's no login, there's no chat feature. All you can do is view content that's up there like it was posted on a message board. So you send an HTTP request that will usually start with the verb get, and then you have a description of what you want to get, and this HTTP version at the end, and then you have to have the host line. All the rest of this stuff is optional. Then you have a blank line at the end, 2 carriage returns. That's the end of the GET request. And then you'll get a response. So there's a request. There are some other things here, like a referrer, which, by the way, is spelled incorrectly. And that is the rule. It must be spelled that incorrect way. And this tells you where it came from. So somebody went from this AOL page to this page where we're getting some CSS. And so this is a privacy flaw. Maybe I better shut that door. That is an issue. Every website you go to sends the URL of the one you're coming from, which is intended to help you understand like which advertising is helping you, but it's something people may not understand. These referrers may expose websites you've been going to a different website. And accept encoding shows what kind of data you'll take. Typically they'll take zip data, which to make it faster, they compress data before sending it to you, and your browser has to unzip it. All right, and so that's your cookie. Down here is additional data you send. This is a Netscape invention. Since the web is connectionless and it doesn't remember who you are, the early web had no way to have any service where you would log in, like an email service where it would remember who you are. So Netscape invented the magic cookie, which is this. You add a cookie header, and it comes from the web server, and now your browser is told to store these things in a local database. Call something AMPV-45, and that's this long thing starting with ADA and so on. All these parameters, name equals value, are stored in a local database by the browser. And then every request back to the same server will send those cookies back up to the server. So even though the server may not remember that you sent a previous request, it will get reminded who you are by these authentication cookies on each request. That's automatically included with every request going back to the same server. And the security of it, such as it is based on the same origin policy. Your browser says this cookie was set by AOL.com, therefore I will only send it to requests going to AOL.com. That's the idea. So the HTTP response will look like this. It will tell you a status number at the first to tell you if it worked. 200 means it found what you asked for and it's giving it to you. And then it gives you a few headers telling you like what version of the server it is and the date. And then comes the data. And here's the data will come down here. And all right, that'll be interpreted by your browser and used to draw part of the page. So here's another HTTP response. This one is setting a bunch of cookies from the server. And in fact, I realized I said this wrong. the cookies are set by the server with the set cookie, and then after that, they're sent up in requests. This is going up to the server, not being set by the server. These are cookie data being sent from the client to the server. This is the server setting cookies. All right. And when you have a banner, it also tells you the name of the server, and there's no reason that this would be correct. It might really be Apache on CentOS, or it might be something else. It is considered a best practice to change this to something generic. There's no benefit in telling random users exactly what version of software you're using, because it just makes it easier for them to find a vulnerability and hack you. All right, the pragma header tells it not to store the response in its local cache. Otherwise, your browser will store a lot of things in local caches so that if you go back to a page and load, say, the same image, it won't get it from the server. It'll just get it from your local cache to make the response faster. And you have an expiration date on these cookies, and also on the server itself, tell you when it expects you'll need a fresh copy of the page. Set cookie has expiration date here too. Setting cookies only are held for a certain amount of time, then they expire and your browser throws them away and would have to get fresh cookies. All right, and so the data type was specified in the content type header in the request, and here's the response in whatever type the request told it to get it off. And it tells you up here, content type application JavaScript. That's what this stuff is. All right, so GET is the most common request. This is used to retrieve resources from the server. You can send parameters in the URL query string. So if you look at a web page like this, if you go to my twitch.tv/Sam Bound, there are no parameters in this, but you could put a question mark and have like ID equals 111 and type equals JavaScript or something. You can put parameters up here in the URL, and they can be read at the server and used for any purpose you like. However, it is not a good practice to put sensitive data here like usernames and passwords, because these parameters are saved in local browser favorites, and they're also saved in server logs. They're not treated in a confidential way. So using a GET request and sending sensitive data with parameters in the URL is a bad security policy. What's better is use a POST. A POST is intended to send data to the server. So you put the request parameters, you could put them in the query string, but the ones in the body are the better place to put sensitive data. So a POST usually performs actions like buying something, and your browser will warn you if you repeat a POST because you may be repeating an action of some kind. You might be buying a second copy of a book or something. And head is the method that returns only the header and not the body, not used very often. Options shows the allowed methods like get and a POST. Put uploads data to the server and is not commonly used in browsers, although it can be used a lot in mobile apps. And so you have a URL, which has got a protocol, which is either HTTP or HTTPS usually. Then you have the host name. You can put the port here. And then you have a path and a file and possibly parameters equals value. This is all the contents of a URL. And if you don't specify the port, then it's 80 for HTTP and 443 for HTTPS. And thanks to Edward Snowden, who leaked out all our secrets, everybody has updated HTTPS in a hurry, exposing that American companies like Yahoo that were using HTTP were being treated as adversaries by our own government and hacked by the NSA that was stealing all their data. And when he exposed that, everybody upgraded quickly to HTTPS, and in fact to HTTPS 1.2 or later, because another attack that the NSA is performing on American companies is they're archiving all the internet traffic in a giant server farm in Utah and holding it, hoping to find the key later on the server, and decrypted it later, and that is only possible with earlier versions of TLS. TLS 1.2 and later uses a different key for every session, so you can't do that attack anymore. And that was something people did not bother to update to until Edward Snowden's exposure made people realize how much the U.S. government is hacking American companies, and they all felt pressured to upgrade to a more modern version of HTTPS. So then there's RESTful URLs. This is another very strange thing about the web. There aren't standards that hold very much. People put data in weird places. So in RESTful URLs, the normal way you'd do this is you would have the domain.com and then search, and then you'd have a parameter like make equals Ford, mod equals Pinto, if you want to search for a Pinto Ford car. This is how you would do it, but some people prefer REST And they do is they take the parameters and put them in the URL as if they were folder names. I don't know why people do this, except to drive us all crazy, but they do. So you send this to the server, and it knows to take these parameters that look like folder names and treat them as parameters instead. So it's one of the many strange things on the internet. Anyway, let's try a Kahoot. 3A is here. All right. All right, so what part of the request is often get? The verb, I've heard it called the method. It's not the protocol. That's something like HTTP. All right. What method requires user confirmation when you click back? Post. All right. Okay, what parameters get stored in bookmarks? Yeah, the query string is what goes in the URL and therefore ends up in the bookmark. All right, which of these is RESTful? This is the one RESTful. Parameters are just stuck in the URL as if they were folder names. All right. Good. All right, and I saw some comments in Twitch. was the 197 orientation should have been at 5, but I did not remember, so I forgot. So I think if you have questions, just come to my at 7:30 I can answer questions about 197, and I'll send an email out to people, and I think I'll tell them just come to my 7:30 question and answer session if they have questions for it at this point. Yes, Jacques, I failed to show up at 5. I completely forgot about it. I'm sorry to waste your time. Especially the people that came here physically, I'm sorry to waste your time. Anyway, all right. So let's go on here. So HTTP headers. Connection tells it whether it should close the TCP connection after the transmission is completed. You can do a TCP handshake, SYN, SYNAC, ACK, open the connection, and then send a whole series of messages without doing another handshake, if you allow that. We mentioned this before. You can determine what kind of encoding is contained in the body, like whether it's zipped. You can specify the length of the body, and you have to, in the case of a POST request, you have to tell it how long the message is going to be. Content type specifies what kind of content is contained there. Transfer encoding can be used to specify chunked encoding, another way to sort of break up your message. And these are general headers. Here's request headers, tells it what kind of content the client is willing to accept, and encoding. Authorization can send credentials. I think that's for the old form of authentication that sends your data in base 64 gathered. I may remember the name of it eventually, but it's in a very old system. And cookies we've talked about. The host name specifies which host name is needed, and it's necessary because now web servers often serve many different websites from the same IP address. So they need to know the host name to know which one to send you. And you can specify when the browser last received it. So if it hasn't been modified since a certain time, it doesn't need to send it again. And we talked about referrer, and user agent tells it information about your browser so it can send a different version of the page to a different browser, and this is typically used to send a smaller version of the page to cell phones. And response headers, the main ones here, it has an expiration date, it has pragma that can tell it whether to cache things, it can set cookies, and there are a few we'll talk about later like X-frame options which can help prevent certain attacks. So cookies are resubmitted in every request back to the same domain. And so you set a cookie with the set cookie response header from the server, and then the browser will attach it to every further request so that the server knows I am the one that you talked to previously, and you marked me with this cookie, so you know who I am, and therefore it can determine what ads to show you, and it can maintain a session to remember if you have logged in. So you don't have to specify attributes. But you can tell it when to expire, how long it'll last, and which domain it's for that's valid. If you want a same domain or a parent of the domain from which the cookie was received, you can't send a cookie from yahoo.com and tell it that that cookie should be sent to ccsf.edu. That's not allowed. It would have to be at your company. All right, and so you can have a path, URL path for which it's valid. The secure flag is very valuable. This means it always has to send the cookie over HTTPS. Otherwise, it can be sent unencrypted, and then people can steal the cookie, and then they can imitate you. And HTTP only is also very useful, so it can only be used for HTTP requests. It cannot be included as a JavaScript request. This stops cross-site scripting attacks that steal cookies, which is one of the most common type of attack we talked about last time. So the status codes are like this. 200 is the most common one, means things worked. I don't think I've ever seen a 100. 300 means you're redirected somewhere else. 400 means something could not be found. And 500 means there's some kind of error in a script on the server. 500 is often what you get when you do an attack and it works. Like you inject code and it runs on the server, taking some action, because unless it actually creates a response, which is a valid HTTP response, you'll get a 500 error, but it often is a clue that your attack is working. All right, so that's a 200 moved to another location in the 300s. Bad request or unauthorized means this is called basic authentication. That's what I was looking for earlier, where you put the authentication in a header, an authentication header. It's a very old system, and not used that often anymore. And then various other ones here. 404 is the most common, of course. You asked for something and it just wasn't found on the server. And 500 means some kind of server failure. And people have a lot of fun with these, making examples with animals and such. So HTTP, and I think it's another Netscape invention, invented secure sockets layer to make it more secure. So now there's an encryption layer on the internet. And so there was SSL, and it was an old encryption method and had some flaws. So they replaced it with TLS, and TLS has had a few versions. And now modern versions of TLS are considered quite secure. Now this protects data in motion. The data you send over the wire is encrypted while in transit, but it does get decrypted at the end, so the data is not protected at rest or in use. You can have proxies, and this is very common. If you can have client-side proxies, where if you have a company and you want to block certain things like pornography or games, then you often force all your users to connect through an outgoing proxy. They aren't allowed to connect to anything directly on the internet. They're only allowed to connect to your proxy, and your proxy will request internet pages and pass them through. And in your proxy, you have a list of domain names that are forbidden, and it won't go there. So that's a client-side proxy. You can also have a server-side proxy, which is what I have. That's what Cloudflare is. So now people trying to go to your web page do not really go to your server. They go to a proxy in front of the server, and that proxy will make the request to my web server and pass it on. This has several benefits. One of them is the proxy server can be closer to you than my web server, so you get a faster response. Also, it can cache the page, so it might not have to ask my server every time. It will just send you a copy of my page, so it increases the available bandwidth. I don't have to pay for such a powerful server. And it also can protect me from attacks. If you send malformed HTTP requests to attack my server, the proxy will absorb those and not pass them on to my server. And these are all services Cloudflare provides for free. So when you hear news and people say there was a denial of service attack and they brought down a server, I always feel like these people are idiots. There's a free service that would stop that from Cloudflare. You can't take down my site with a denial of service attack. In fact, you can't even find the IP address of my site. It's hidden behind Cloudflare proxies. So unless you can take down Cloudflare, you can't take down my site, and they have one of the biggest server clusters in the world. Almost nothing can take them down. So there's no reason to let anybody take your website down anymore. There hasn't been for a long time. All right, and so man-in-the-middle attacks. This is a problem with HTTPS. You can, well, to be fair, HTTPS does have a defense against this. So the point is it uses public key cryptography and end-to-end encryption, and so you connect to the server sends you a certificate, and then your browser validates with a trusted third party that that certificate is actually tied to that domain. So it not only is your data encrypted, but you know the identity of the server you're talking to. And therefore, even a man in the middle cannot fool you if HTTPS is being implemented correctly. This is a problem for companies. If companies want to restrict HTTPS traffic, they can't read it. So what they have to do is put a man in the middle. Now, the only way to do this is to violate the security policy of the web, and it does happen all the time. They have to purchase certificates so they can impersonate a trusted certificate authority. And those are not supposed to be sold, but it is a sort of open secret that they are sold to large companies and police departments, so they can actually man-in-the-middle HTTPS connections by having a real certificate authority, so they can pretend to be a certificate authority authorized to intercept your traffic. That is a disturbing thing. By the way, the correct way to do this is to install a proxy and then have it and add it to the trusted store on your company machines. So they will trust it, but nobody else would trust it. But if people bring in cell phones and laptops from home, they won't be able to reach the internet without getting warning messages unless they install that trusted certificate. That's the correct way to do it, but a lot of companies instead somehow get a copy of a trusted root certificate and use it.
So do you need a certificate for Cloudflare and the site you're trying to reach?
No, in my case, my server is only HTTP. Cloudflare adds the HTTPS. So they're the endpoint. If my server was serving HTTPS, then I wouldn't be able to put a proxy in the middle without doing one of these dirty tricks. The proxy would have to have a fake CA certificate, or I'd have to tell my viewers to install something. So that's how I do it. Good. So in a proxy, you send an HTTP request to the proxy. If they allow it, they keep it open, and then it acts as a TCP level relay to the destination web server. So it's just forwarding all the traffic. It can't read it, but it's forwarding it. So this is basic authentication. I mentioned before, that takes your username and password, base64 encodes it, and puts it in an authorization header. NTLM is an old-fashioned one, not used that much anymore, where you log into a website using the same kind of hash you would use to authenticate on a Windows local network. And Digest is another strange one, not used that much on the internet. All these are very weak cryptographically, and if they're sent over HTTP, they expose your password, so you should send them over HTTPS, and that puts another layer of stronger encryption on them, which is pretty much what everybody does today. HTTP is almost extinct. Very few sites are using unencrypted HTTP. It is always unsafe to use HTTP because even if you're loading non-sensitive content, anybody can be in the middle and modify it, and they can add scripts so they can run code in your browser. If you have any HTTP connection, even to load an image or an ad or something, someone could add scripts to it, and they would then run in your browser. So it's considered poor practice to use any form of HTTP anymore. Very few people do. So let's see. Here they are. We'll try another one of these. All right. All right, so what request header tells the server what page you're coming from. Yep, that's the referrer, okay? All right, where can a server specify that you must always encrypt the cookie? Okay, in the set cookie header, you add the secure flag. And that tells it, remember this cookie, but only transmit it over HTTPS. Of course, you're trusting the browser to do that. The server has no way to verify if your browser actually obeys the rules, but a compliant browser will. All right, what status code indicates the page was not found? This all the time. I don't see it that often anymore. I think web designers have gotten more professional and they have me custom pages. Anyway, that's 404. All right, what transport protocol does HTTPS use? It's all TLS. It's not SSL. It hasn't been for more than a decade. All versions of SSL are insecure and have been deprecated, replaced by TLS. All right, let's carry on here. So, the web functionality on the server side, if you have a simple page like mine, it's just pages and images that are the same for all users just sitting there. But you can have dynamic content where you custom create responses for each user, run by scripts on the server, fetching data from databases, so you recommend different products for different customers, and you let people log in, and then you let them see, say, their email and not somebody else's email, and so on. You can send the parameters a lot of ways: in the URL query string, in the file path of REST-style URLs, in cookies, or in the body of requests using the post method. These are all ways to send parameters to the server. You can also, in principle, you can send anything. You use the user agent and so on. You can configure your scripts on the server to read any part of the request and do anything with it that you want. You have scripting language running on the server like PHP or any of these other languages. You have application platforms running ASP or Java. Web servers themselves, typically Apache or IIS are the most common ones for Linux and Windows. And databases are typically running on your in your group of servers. So many different servers are working together to create the pages, and you have other back-end components. And so the modern web page is like a whole company with several different servers, different roles, sending messages back and forth, assembling the page that's sent to you. So it gives many opportunities for a hacker to send a message that will be misunderstood by any of those servers and let you in. So Java is intended for large-scale enterprise applications with large server clusters. It's difficult to program in, and they pay the programmers well because they make enterprise-class applications. Small-time people usually use things like PHP, but this one is suited to modular development and code reuse. So enterprise Java Bean is a heavyweight software component. Plain old Java objects are the user-defined objects sent up to it. And Java servlets are little objects that receive requests from clients and return responses. These are some of the components of Java-based servers. And Java web containers are another thing they use up there, like Apache Tomcat, an engine that provides a running environment for Java-based web applications. All right, and so you'll have authentication. We'll use technologies like these. There's a presentation layer, there's a database relation mapping, and logging, Log4j, which is famous for having a tragic security vulnerability about 5 years ago that was monumental, that affected all kinds of companies and government agencies. Everyone freaked out. It turned out there was a command injection through Log4j. So everybody had to audit all their machines using it and then up-patch it and so on. It was a big scandal. ASP.NET is Microsoft's competitor. Instead of using Java, you can use ASP. It's intended to serve the same purpose using the .NET framework. Java applications run in a Java virtual machine. That's how they can be platform independent. ASP applications run on the .NET runtime, which in principle is can be run on different operating systems, although I've never seen anybody run it on anything other than Windows. And you can write the application in any of a variety of languages, like C# or Visual Basic, and it will compile it down to common language runtime, which is not assembly code. It's sort of a meta-assembly code that runs in the virtual machine, the virtual environment of the ASP, of the .NET runtime. And if you take the malware analysis course or the exploit development course, we hack into this stuff, and you can see how it works at the binary level. So Visual Studio is the Microsoft's development environment for many languages, including ASP, and it's very easy for developers to use. I know a lot of professional developers won't do anything except in this tool. They don't want to hear it. That's why they have versions of it where you can write code for Linux in Visual Studio. I was surprised to see this, but a lot of developers are just addicted to this tool. They don't want to use anything else. All right. And PHP is more for cowboys. It's for making small companies and personal web page. That was originally intended for a personal homepage. It does not scale to large applications. but it's fast and easy to use. It also tends to have many serious security vulnerabilities. There's a famous web platform that's run on PHP that has an endless series of vulnerabilities. Here's some examples. PHP Nuke, PHP BB, PHP MyAdmin to administer it, and some mail and shopping carts and wikis and so on. There's a lot of PHP-based code out there. It's going to be used by blogs and smaller websites. Ruby on Rails is another one that I heard very popular a few years ago. I don't hear it being used that much anymore. Ruby is a very beautiful language written by a Japanese developer, very logical, but it seemed to sort of come and go in popularity. Now, when you have a database storing a bunch of data, you always access it with a structured query language. And there's Oracle, there's Microsoft's version, and there's the open source MySQL. And these database languages are used to insert data, to read data, to change data. And there are serious vulnerabilities with all of these. They're subject to SQL injection, which I'll demonstrate next time, one of the most powerful attacks on the web. That's the problem. If someone is able to inject SQL code, they can read data from your database, which is typically confidential data like social security numbers, credit card numbers, and things like that. It was the way the vast majority of all data on the web was stolen until about 5 years ago. Like more than 90% of all stolen data was stolen by SQL injection. And this ended not because SQL injection became less common, but because Amazon provided Amazon storage buckets that were world readable by default, and many people didn't notice that, so they just exposed all their data to the internet, and that created a flood of stolen data, which outclassed all the SQL injection. And to be fair, the breach 2 weeks ago of the National Data Service, or something like that, dumped essentially every American's personal data for the last 10 years everywhere, and it's totally public now. So that probably dwarfs all the others. So this is why there's so many jobs in security. We're all failing. Things keep getting worse and worse. People keep getting hacked. The hacks keep getting bigger. So the only thing they can do is hire more security engineers to try to patch the holes. So it's job security for all of us because we're so ineffective. That's the situation. Anyway, XML is a way to encode data to send it to the server. You put it in tags like HTML, pet, and /pet contains the name of a pet. And pets are here, and then you have a dog and a cat, and so on. This is containers, and this is now a standard way to format data to send it over the internet. And since 2008, Microsoft Office stores everything in XML. They had their own proprietary binary formats, and they finally wised up and said, we should just store data in plain old XML. It's easy to search, easy for everyone to use. They store XML documents, and then they're zipped with PKZip. That's all Microsoft Office documents are now. Much better than the old binary formats, which required a custom interpreter for anybody that wanted to use them. For example, for e-discovery, if you get sued and you say, now I have to search through all our documents for the last 7 years that pertain to this customer or this product, you couldn't search proprietary binary Microsoft Office documents, but now you can because it's just stored in plain readable text. Right, and there's also something called Simple Object Access Protocol that uses HTTP and XML to exchange data. So you send a post, and the way the post works, you have a header, and then you have a blank line, and then you put the post content down here, and here it uses XML to specify this data. So it's one way to make requests to the server and get data back. Simple Object Access Protocol, that's the request, and here's the response, which again is just formatted with XML. All right. And so if user-supplied data is included, it can have code injection vulnerabilities. XML can have code injection vulnerabilities because if you have a opening tag with a less than and greater than sign and a closing tag here, if I was able to put greater than and less than signs in my content, I could fool it into thinking that this tag ends earlier and some other tag is begun. So like SQL injection, like command injection, if the data is not filtered, you can input control codes in your data which cause the server to misunderstand them as commands, which it runs on the server. And that's the essence of almost all web attacks. You send data that was just supposed to be data, and you trick one of those servers into treating it as commands. And now you have the ability to make the server do things that violate its security policy. All right, so that's the game. And let's take a look at another Kahoot, which is this one. All right, I guess we got everybody who's coming. All right, so what system uses POJOs? It's a hard one. Those are plain old Java objects as part of the Java ecosystem. It may seem silly to learn these terms, but you often have to spot the technology on a server by noticing a few names of objects to give you a clue what operating system they're running or what technologies are being used, so you can figure out how to attack them. All right, what language is used on LAMP servers? It's the most common type of web server: Linux, Apache, MySQL, and PHP. And PHP is the programming language used on it. That's what I'm using. This is the most common server used by small business. Large businesses use Microsoft servers typically, but small ones use Linux servers, LAMP servers typically. All right, what system looks like that? That's XML with these opening and closing tags. All right. And what system uses WSDL? I didn't notice it going by myself today. Must have been in the slide. So web services description language, I think. Let me just go back to the slides and find out where that was. There it was. I didn't mention it. This is web services description language is used by SOAP. All right. All right. So at least it's right. All right. All right, well, good. All right, well, it's 5 minutes to 7. Let's take a 5-minute break. We'll pick up, or a 10-minute break. We'll pick up at 7:05. I'm going to stop the recording.